Okay, we're working on variance and standard deviation. And these are two things that we use to, again, to judge a set of numbers. Again, if I give you like 1,000 pieces of data, how do we concisely look at this and express these in a way that someone could use instead of just giving them all 1,000 numbers? So this is very similar to, again, what we talked about before about mean. Our mean, absolute deviation. But today, we're going to change, instead of using absolute, we're not going to use this absolute. We're going to use a square. And that's going to give our numbers a little bit of a different look. And we'll talk about how to apply these later on. But today's homework assignment, we're really just learning how to calculate them. Okay? How to calculate mean, standard, how to calculate variance and standard deviation. Okay? We'll learn to apply it later and how that looks on a graph. But today, we're just going to work on how to find the number. Okay, so our first part is, let's look at an example. The example will be the numbers 8, 9, 6, 2, and 5. 8, 9, 6, 2, and 5. Now, like what we talked about before, we oftentimes use the mean. And then we're going to use the mean again. The mean is going to help us judge how far. We're going to use our mean to compare all the numbers to. So first thing we do is we find out what the mean, the average. So we add up 8 plus 9. So we find our mean, x bar plus 8 plus 9 plus 6 plus 2 plus 5. And then we divide that by the number of terms. And we have 1, 2, 3, 4, 5 terms. Sorry. So on a calculator, I'm going to take a calculator on the side. I'm going to add up 8 plus 9 plus 6 plus 2 plus 5 equals, divide that by 5. That gave us 30 divided by 5, which is, oops, that's 30. So, yeah, sorry, and that becomes a 6. So on average here, all the numbers are kind of like around 6. But if you really look at it, look at the 2. Is 2 really around 6? Is 9 really around 6? I see 5 and 6. These guys here are really good, right? Those are really close to the average, the mean. And then 8 and 9 were kind of far away, and 2 was kind of on the low side. So our idea here is, if I just threw all my numbers in a box and shook it around, they would all fall to about 6. Now, imagine if you were trying to share this information with me. And you said, well, I have a group of people, and the average is 6. I mean, imagine if this was me selling you some type of collectible, maybe some baseball cards. And I said, no, what, their grade, their average quality is about a 6. Well, you have some really good cards labeled a 9 out of 10. Maybe you have some really bad cards, which are 2. But when I told you an average of 6, I'm thinking, these are not the greatest cards in the world. But I didn't expect to have a 2 in there. So what happens is, the idea of variance and standard deviation specifically, it tells us how far do these numbers deviate from the mean. How far, again, is that spread? So kind of similar to mean absolute, like we're trying to figure out how wide do those numbers go. So how far are the numbers spread out? Are they really super narrow? Are they really like really far apart? Okay. Okay, so from here is where standard deviation and mean absolute deviation differ. So in order to find standard deviation, we need to find something called variance first. And variance is using this symbol sigma. It's like an O with a little hair on it. Okay, it's an O and then put a little circle on top. Not circle, like more like a dash. Okay, and this is what we call sigma. It's a Greek letter. And we're going to label variance is labeled as sigma squared. Let's look at a definition over here. Variance is the square of standard deviation. So sigma is going to be for us standard deviation. So variance is the squared version and sigma is the unsquared version. Okay, so we're going to look for variance first. And once we find variance, we're going to find sigma, our standard deviation, by taking the square root of that number. Okay, so to find variance, just like very similar to, again, absolute mean deviation. So don't get too scared. It's actually quite simple. We're going to take all our numbers and we're going to subtract it from the average. Except variance here does something a little different. We're going to square the numbers. So I'm going to label this as, we're going to take x bar minus, for the first term, plus x bar, the mean, minus our second term, squared, plus x bar minus our third term, so on and so forth. Okay, and then we're going to divide that by the number of terms. We'll call that n. So variance squared is this idea of, you want to take the mean, here's our mean, minus each term. Very similar to what we did with our absolute deviation. Except in absolute, if you remember absolute, our MAD, call it MAD, we did x bar minus x1, and then we did the absolute value of that. Then we did the same thing down the line. And then we divide that by our number of terms. That's how we found our mean average, mean absolute deviation. So for standard deviation, we want to find variance first. And variance is calculated, again, using our mean. And we subtract our mean from each term. Mean minus the term. Mean minus the term. Mean minus the term. And one reason why you do this is because you don't have to find the absolute value. Absolute values are a little bit ambiguous sometimes. Imagine if you're trying to tell someone, like using words, take the absolute value, just make it positive. Okay, that sometimes is a little difficult. So instead we use a square, and our square is going to make all the numbers positive, whether it's negative or positive. So that's a square here. So let's go ahead and do that with our numbers here. We said our average was 6. So we're going to say 6 minus our first term, which is 8. We're going to square it, plus 6 minus 9, square it. Oops, other way around. Darn it. Doesn't matter. It's fine. Plus, sorry. 6 minus 6, square it, plus 6 minus 2, square it, plus 6 minus 5, square it. Take all these values and divide that by the number of values we had, 5. So when we do that, we're going to say 6 minus 8 is negative 3. When a square becomes a 9, plus, sorry, what I'm doing, that wasn't 9. 6 minus 8 is negative 2, and we square it, becomes a 4. I'm sorry, 4. Over here, 6 minus 9 is a 3. 3 squared is a 9. Plus 6 minus 6 is 0. 0 squared is 0. 6 minus 4, no, 6 minus 2 is 4. 4 squared is 16. And 6 minus 1 is, 6 minus 5 is 1. 1 squared is 1. All divided by 5. Adding them all up. 4 plus 9 is 13. 13 plus 16 is 29. 29 plus 1 is 30. 0 over 1. So variance is 6. This is our variance. Now, from here, we only have one more step to get to standard deviation. And the standard deviation is just a square root of variance. So standard deviation is, we said, is sigma. And how to get from square to non-square is we take the square root. So we take 6, we take the square root of 6. So this would become, oops, I'm getting on my calculator, 2.449, which I'm going to round up right now to 2.4, round down, if it's one decimal place. Okay, let's do one more example. Our numbers are going to be 2. It's going to be 2, 7, 9, 6, and 6. Okay, 2, 7, 9, 6, and 6. So our first step is to find variance. That's sigma squared. So we're gonna, sorry, not sigma squared. Our first goal is to find the average, the mean, so we can compare all our numbers to. So we add up 2 plus 7 plus 9 plus 6 plus 6. We're divided by the number of values, 5. And that's 9 plus 9 is 18. 18 plus 12. 18 plus 12 is 30. 30 over 5 is 6. So now our average value is 6. Then our next goal is to subtract our mean value from all the other terms. So we're going to say 6 minus 2 squared plus 6 minus 7 squared plus 6 minus 9 squared plus 6 minus 6 squared plus 6 minus 6 squared. Over the number of terms, we said 1, 2, 3, 4, 5 terms. And that's going to be our variance. So this could be a lot of work if you had a large set of numbers. Let's say we again had 100, if you had 1,000. But the cool thing in modern day, what we do is we don't do this by hand. We do this with an Excel sheet. And on Excel, you could set this up where you subtract a number from another number. And you can create a formula of this actually pretty quickly. It takes me about 5 minutes. Okay. And then so let's go find the variance. 6 minus 2 is 4. 4 squared is 16. 6 minus 7 is 1. 1 squared is 1. 6 minus 9 is 3. 3 squared is 9. 6 minus 6 is 0. 6 minus 6 is 0. All over 5. Okay. We add those up. 17 plus 9 is 26. Is it 26? Yeah. And we're dividing that by 5. That gives me 5.2. 5.2 is a decimal. Oh no, that's fine. Because our next step to find standard deviation, we just take the square root of 5.2. So on your calculator, type the 5.2, take a square root, and that's going to be 2.28. And if I want to round it, it's approximate 2.3 if I'm rounding the nearest 10th. Okay, so pretty much that's it for today, us finding standard deviation. Let's go and look at the IXL, see what that looks like. Oh wait, give me a sec. I'll give you some time to copy this if you need it. So the step 1, find the mean. Step 2, go ahead and subtract each of the mean values from each of the points in the data set. 6 minus 2 squared, 6 minus 7 squared, 6 minus 9. In mean absolute deviation, these are all absolute values. So the step is very similar to it. So the thing about variance and standard deviation versus mean absolute, is that once I square it, aren't the numbers really big? And that's why we square root of it. We square root to bring it back down. So the mean absolute deviation, you don't have to do a square, but in variance and standard deviation, you square it first to make it big and positive, and you square root it to make it back to a regular number. Okay, so let's now go to IXL. So in IXL, you see problems that look like this, and they're going to ask us to find variance. Well, the problems here have 8, 8, 2, 5, 8, 2, 9. Okay, let me go ahead and pull up our, oops. Okay, so let's do the same thing with this data set. We're going to say find our mean first. Let's go to find our mean. Our mean is going to be 8 plus 8 plus 2 plus 5 plus 8 plus 2 plus 9 divided by the number of terms. 1, 2, 3, 4, 5, 6, 7. We have 7 terms. I'm going to take my calculator on the side, add them up. 8 plus 8 plus 2 plus 5 plus 8 plus 2 plus 9. That gave me the number 42. 42 divided by 7 gives me a magical number 6 again. Wow, that seems to come up a lot. Then our next step to find variance, so sigma squared, we subtract 6 minus 8 squared plus 6 minus 8 squared plus 6 minus 2 squared plus 6 minus 5 squared plus 8 plus 6 minus 8 squared plus 6 minus 2 squared plus 6 minus 9 squared all over the number of terms that we had is 7. So it's almost, the idea is that we're finding the average of the square distances. Average of the square distances, because we're adding up all the terms, we're subtracting all the differences, and we're squaring them. Now, this will be something like a big number, but we can rewrite it before we divide it. So we can say 6 minus 8 is 2. 2 squared is 4. 6 minus 8 is 2. 2 squared is 4. 6 minus 2 is 4. 4 squared is 16. 6 minus 5 is 1. 1 squared is 1. 6 minus 8 is 2. 2 squared is 4. 6 minus 4 is, 6 minus 2, let's write that. 4 squared is 16. 6 minus 9 is 3. 3 squared is 9. All over 7. So our variance here, I'm going to use my calculator now. 4 plus 4 plus 16 plus 1 plus 4 plus 16 plus 9. That gave me the number 54. 54 over 7. Divide that number by 7. And we're looking at 7.71, which is, approximately 7.7, because they want us to round off the nearest tenth. Here's some right, 7.7. Wait, yep, yeah, that's right. Okay, they want a variance. I'm gonna submit that. Oh, good work. Whew, no, that was close. And if you look at the SMART score actually jumps up pretty quick. So they only have a couple of these problems for you guys to try today. The next one is standard deviation. And let's do this problem. Pause for just a moment. Okay, let's do this last problem. So standard deviation, we have to first find variance. So our first step is to find our mean, x bar. Okay, find x bar. We're gonna find x bar by adding them up and dividing by the number of terms. 1 plus 5 plus 7 plus 4 plus 3 plus 7. That's 6 terms. On my calculator, 1 plus 5 plus 7 plus 4 plus 3 plus 7. We have 27 here. And we're going to divide that by 6. Okay. And that gives us a decimal of 4.5. Okay. Now to find our variance. So because it's a decimal, it's going to be a little bit more work for us. So we just want to make sure our work is clear. So we're going to take 4.5 minus 1, square it, plus 4.5 minus 5, square it, plus 4.5 minus 7, square it, plus 4.5 minus 4, square it, plus 4.5 minus 3, square it, plus 4.5 minus 7, squared. As you saw what I did, I took the mean and I subtracted from every point in our data set. And then we divide that by the number of terms, 6. We're finding the average of all the differences squared. Of course, this one will be a little harder when it comes to write on the calculator. So I'm going to subtract it first. 4.5 minus 1 is 3.5. And then I can square that on my calculator. And 4.5 minus 5 is 0.5. I'm going to square this. And then we're going to take 4.5 minus 7. So if you want to try to do this in your head, think of it as $7 and $4.50. $7 minus $4.50 is 2.5. 4.50 minus 4 is 0.5. $4.50 minus 3 is 1.5. And 4.5 minus 7 is 250. I'm going to square that all over 6. Now, I would highly recommend you now just go ahead and do this on your calculator. Just do that on your calculator. Let me see if, no, I'll just do it on side. Okay, 3.5 squared. You have a square button on your calculator, plus 1.5 square button on the calculator, plus 2.5 square, plus 0.5 square, plus 1.5 squared, plus 2.5 squared, and I'm getting on top 29.5 over 6. You can double check that yourself. Once I divide the 6, that is going to be 4.916, rounding up to 7, rounding up. Now, what I want to do is to find standard deviation. If you look on the left, standard deviation says that this is not sigma squared, it's a sigma. So to go backwards, we're going to take the square root of it. So sigma, our standard deviation, we're going to take the square root of 4.917. So my calculator, I'm going to go take a square root of that, which is just one button. That's going to give me 2.217, which is approximately, for us, rounding off is 2.2. Let's try on my left. If 2.2 is my answer, 2.2. Hopefully I didn't mess up. I named all the small steps. Oh, 2.1. Wonder where I messed up. All these numbers. Oh, I messed up here. I wonder where I messed up. Oh, 0.5. Let me see. Did I misadd it? I wrote 29. They wrote 27. Maybe I subtracted wrong someplace. 5.5, 2.5. Did I miss copying the terms? 1, 5, 7. I must have added it wrong. Okay. Well, at least I know where I made the mistake. So make sure if you guys do make a mistake like me, you can go take a look at where like I messed up and where they messed up. Okay. All right. If you guys have any other questions besides a simple mistake, please let me know.